Okay, let's start. I think. Fine. So yesterday, I think we had looked at the concepts of networking and networking concepts. Fine. We had seen mainly what we had seen. We had seen the layers, like starting with the physical layer. Fine. The physical layer was nothing but the hardware. And next was, we are looking at it from TCP/IP point of view. So we'll have only 5 layers here, right? What was the next layer? Data link layer. Okay, fine. This is nothing but it is in the normally in the firmware of the NIC. Fine. Data link would be present in the firmware of NIC, where MAC address, right? What was important was we had the MAC address. Okay. Next layer we had found was network layer. Yeah. And here the options, it's all going to be software from the OS. The option is to use IP protocol. Fine. Okay. IP protocol, we had various versions, but version 4 and version 6, IPv4, IPv6, two options commonly used with IP version, IP protocol. And so what we have here, identities, IP address. Okay, fine. Then what was the next layer? Transport. Fine. For transport, we had options like TCP or UDP. Fine, this was connection oriented. Fine, or you can call it as stream based. And UDP, connectionless and packet based. Fine. We had compared TCP with a telephone. It's just similar to a telephone connection. And UDP was similar to postal mail, right? Okay. Fine. Fine. We are mainly concerned with TCP here. Okay. We have still got a next layer, right? Now just think about why we need one more layer. What is this TCP giving us? A mechanism for exchanging bytes, right? A mechanism for exchange of bytes, fine. So it's like, okay, you can make a call to someone, right? But just making a call, is it sufficient for communication? In real world, yeah, you can make a call, you can connect to some service, you can maybe connect to a service somewhere. Is that sufficient for communication? Having got the connection, is that sufficient for communication? What is needed for communication? Yeah, you are given a channel, right? You have a channel, a stream-based channel on which bytes can be exchanged. Is that sufficient for communication? And as an analogy, just think about this. What would happen if you make a call to someone in China and speak in Hindi? Yeah, the voice goes, the phone, the mechanism is there to send my voice. There is a mechanism, you are hearing some voice, but it is not meaningful, right? And therefore it's not a communication. Fine. So yes, we need a meaningful exchange of bytes, fine, which can be understood by both the client as well as the server. The communication happens only when client understands what the server is saying and server understands what the client is saying, right? Only then it is a communication. If one person doesn't understand what the other is saying, it's not a communication. Clear? So transport layer is giving us the infrastructure where bytes can be exchanged. But to have a meaningful exchange of bytes, and therefore what we have is the application layer, right? So at application layer, you have various protocols. For example, we have the HTTP, right? Fine, SMTP, POP3, IMAP, and so on. There is one called DNS also. And so there are various protocols, right, which are meaningfully using this transport layer. Fine. They have a well-defined syntax of how a request is sent by a client and in what format the response is given by the server to the various requests coming from a client. And it is normally client-server communication, client sending some request and server giving back a response to it. Okay, that's a normal course of action. Fine. So in our case also, fine, what we need is, we need this kind of a thing. We need some application protocol. Now, okay, as an exercise, what we have done, what have we done? We have created earlier a class called bank clerk, and what do we have there? A well-defined set of commands. And think as those commands which can be understood by some server. We may have a server which understands those commands and it is giving the responses in a well-defined format. Comma separated values are coming, right? So, so that's again, you could think of it that as your own protocol for connection to some kind of a server. Fine. So later we'll try to do that thing. Fine, we'll have that as an example for this. Okay, so find a meaningful action, that is what we need to achieve. We can have our own protocols as well, but these are some standard available protocols, and which are used. Okay, fine. So now continuing with this, at transport layer, now what Java gives us is, it gives us things at the transport layer. We don't have to worry about the lower layers like the data link layer, the network layer or anything, as far as Java is concerned. As a Java application programmer, you don't need to worry about the network, data link and the physical layer. Of course, you should be knowing what is the IP address of a particular machine which you want to connect to, but how to manage objects of certain types, no, you don't have to worry much. Okay, so let's see what else we can do here. Okay, fine. What we have here is, let's talk now about the java.net package. And yesterday we talked about all the concepts. Now today we'll talk about Java. And we didn't talk about Java yesterday at all. Okay, fine. So we'll talk about java.net package. In this package, we got a few classes. We are looking more from the point of view of a server. Fine. Fine. Yesterday we did talk about how a server behaves. How does a server behave? When you start a server, what would it do? It has to acquire a port. It must say, oh, I want to give service on a particular port number. So it goes and asks for that port number from the OS. Fine. For this purpose, what we have in Java, okay, acquiring a port, fine, and even start listening for some client to connect. Yeah. So for that kind of a thing, what we have is in the java.net package, we got a class called server socket. Fine. There is a class called server socket. Fine. We'll look at the most commonly used things from the java.net package, fine, for achieving a TCP/IP communication. Okay, so what we have in the server socket class is, yes, the server socket class has got a constructor where it takes integer port number as a parameter. So when you create an object of server socket, okay, a successful creation of server socket would mean you got the port number. You have acquired the port number. Fine. If the port is already available, the constructor would throw an exception. Yeah? The constructor for server socket is nothing but acquiring a port. So if you write a server-side application, fine, first thing you'll do is, okay, I want to acquire a port, fine, where I'll give service. This is for that. Fine. Creating a server socket not only is acquiring the port, but it starts listening for connection. It even starts listening for connection. If someone client connects, yes, he'll get, I'm successfully connected. But then we need something more than that. Fine. What we need here, okay, so for client server communication, let's talk about what exactly is happening. On the server side, okay, let's think on this, let me put this as the server side. On the server side, one object of server socket can be created. Fine. The meaning is it has acquired a port number. Fine. It has acquired a port number and it is listening for a connection. Right? This is what the server is ready, listening for a connection. If a client wants to connect, what should the client know? What the client is supposed to know? The client is supposed to know the port number, the IP address, right? Whatever is the IP address of the machine where this server socket object has been created. And what is the port number of the server socket? That is something which should be known to the client. Okay, so here is some client. Yeah, what does a client do in this case? I want to make a connection. So what should I do? It must acquire a port. So locally it must acquire some number from the local OS, and then it should know, yeah, what it should know? Two things: IP address and the port number where the server is listening. I want to connect to some server who is listening on that port number. Okay, fine. So for that, what he does is what the client does now. What the client does is client uses the constructor of socket. So client creates an object of socket. Okay, socket we have another class, like we have a class called server socket. Okay, we also have a class called socket. The socket class takes two parameters in the constructor. It takes a string, and it can take a string for the host. What is the host? Here, as a string, you might give an IP address or you might give a host name, which can be resolved to an IP address. Fine. And second parameter can be the integer for the port number. Fine. Socket can be created by specifying host and port. Okay, so what exactly happens? This socket creation would be successful only when? When would it be successful? When there is a server, there is some server process on that IP address listening on that port number. Fine, if there is some server socket which has already been created and ready, waiting for someone to connect. Okay, so we have server socket here. Now this one is using this port number, but when it does this, fine, it will get connected. So yes, it will require some resource, and this connection would be made. It will require some resource on this side. Okay, what exactly is happening when he creates a socket also gets created on the server side. Two sockets are created. When client calls a constructor of socket, fine, a successful creation of this socket also implies a successful creation of socket on the server side. Okay, clear? Two sockets are created. So there is another socket which is getting created, which is part of the server socket now. It is fine. It is there in the server socket. With the server socket, a socket object is created and managed there. Fine, because it was listening for someone to connect. Fine. Now what we have here, Let's look at another thing which is from server socket class. As far as client is concerned, client calls the constructor, he's made the connection. If this constructor is successful, connection is done for the client. Fine. Now, as far as the server is concerned, on the server, yes, there was a server socket, but because some client has connected, a socket object would be created, fine, and you want that socket object on the server side. Clear? What is required on the server side? Oh, first, he calls the constructor of socket, creates an object. Server side code is different. Client side is a parallel codes running on a different machine. When these are two different machines. So here is one code which says, okay, use the constructor of server socket, and in the second step here, so there are first step is create server socket. Okay, it's waiting. Fine. This starts waiting for someone to connect, acquires port and starts waiting. Fine. Okay, what would happen is we have a method here called accept without any parameters. There is a method called accept in the server socket class, does not require a parameter. What this method would do is, if there was some connection already which was done, okay, fine, there would be a socket which is created here. That socket is returned by the accept method. So we have the accept method returning that socket object from the server socket. Okay, fine, we have the accept method to return the socket object from the server socket. Fine, the socket object comes into existence because some client has connected. If no client has connected, there won't be a server socket. When you call accept method in such a case, what would happen? The accept method blocks. It just waits. The accept method would not return. You called accept method, yes, it is at this step called accept. Why? Because I don't see any socket. As soon as a socket would be created here, that socket object would be returned by the accept method. So accept method returns as a next socket connection from the server socket. Server socket gets a socket connection because of a client making a connection. How does a client make a connection? Calling the constructor of socket. Fine, it calls the constructor of socket. That's how it makes a connection. Okay. Fine. Now something about the, so server socket, we saw two methods as far as server socket, two things. For server socket, there are two things. So as far as server side is concerned, it does two steps. First step, creating object of server socket. Second step, calling the accept method. Fine, calling accept method, if no connection was done, starts waiting. If connection was already done, gives us that socket object, existing socket object. Okay, or else it would start waiting for a connection from the client. How does the client make a connection? Calls the constructor of socket. But calling constructor of socket in a client results in two objects being created. Clear? For the client side, yes, it's only one object, but it also results in a socket object created on the server side. Clear? So when we call the constructor of socket, we say there are two simultaneous socket objects created, one for the client and other on the server side. Okay, fine. Now, so what would happen? Both sides have a socket object. Clear? One socket on the server side because of accept method, the other socket on the client side because of the constructor. Fine. So now we have two different programs running on two different machines. Fine. Both of them having one socket object, but this socket object is a connected socket. How? Oh, because now what does this socket have? We say these are two connected sockets. When calling the constructor of socket, if it is successful here, it results in two connected sockets being created. Oh, how do we say they are connected objects? Because what does a socket have? There are two important things in a socket. What are the two important things in a socket? A socket object would have two things. it would have a input stream and it would also have a output stream. It's a stream-based connection. Recollect, TCP/IP is a stream-based connection. It has an input stream and output stream, and we are saying this is a connected socket, and therefore, see the socket which is on the other side. Here also there is one socket created. This socket also has its own input stream. Oops. ये क्या होगा? Blank हो जाएंगे? One second. Let's check. Okay, anyway. Something was lost? Yeah. Yeah. So this socket here also has an input stream and a output stream. Fine. This is for the socket which is created here. Okay. And these two sockets here are said to be connected because what we have is something like this. This is input stream here. That's our input stream over here. This is the output stream over here. The two are connected because, oh, what do we do on an output stream? We write something. The two are connected because anything which you write to this particular output stream over here on the client, let's say, this is available for read on the input stream on the other connected socket. Two sockets connected, right? Because the two sockets are connected, each socket has an input stream and output stream of its own. Clear? The input stream of the socket reads whatever is written on the output stream of the connected socket. Clear? If you try to read anything on an input stream, so if I try to read on this input stream of the client, it would be reading whatever is written on the output stream here. This is the output stream of the socket on the server side. So you write anything here, that flows and goes to the input stream here. Fine, it's a cross connection. Clear? Input stream is able to read what is written on the output stream of the connected socket. Input stream of a socket always is able to read what is written to the output stream of the connected socket. Fine, I think I'll put it again. Okay, the diagram goes like this. We got two connected sockets. So think of two connected sockets as, okay, that's my socket 1. It has an input stream and it has an output stream. Fine, we can put it maybe inside the socket object, the part of the socket object. Okay, so that's my socket 1 and that's my other socket which has its own input stream and output stream. The two are connected because anything which I write to the output stream here flows. It flows and is available for read over here. So when I read here, I get this. Fine, I get the things which was written here. When someone writes here, it's going to be available for read on this machine. Clear? This is how two connected sockets are there. So you read out from here. And you write on this socket. Two connected sockets are connected like this. Each socket has an input stream and output stream. So in the socket class, okay, our socket class, consider the socket class. The socket class has methods like, it has a method called, it has a method to return the input stream. And method name is get input stream. And we also have another method to return the output stream. Name of the method is get output stream. And two simple methods to give us the input stream and output stream in any socket. Fine, whether the socket is on server side or client side doesn't matter, socket has these methods. Fine. Once the connection is done, they are two connected sockets. They have an input stream and output stream. It is between these two sockets to decide who sends data first, who writes first, who reads first. All that has to be decided by them. Fine? Okay. What we also have here is we got a few other methods in the socket class. There's a method in the socket class. See, what can go wrong here for communication purpose, right? If the communication is not properly designed, right, what can happen sometimes is the client and server both may start waiting for the other one to write something. The client thinks it is the server's turn to send some data. Let me wait on this input stream. He's not writing anything. He's saying, okay, the next message has to come from the server. And the server is thinking, oh, the thing has to come from the client. I'm reading on the input stream of the socket, which is available on the server side. If both start reading on the input stream, what's happening? Nothing. Fine. No one responds. Clear? Something can go wrong, right? So that's kind of thing which can go wrong. Now, to handle with such things, what we have here is, we have a method in the socket class which returns void. Name of the method is set SO timeout. And takes as parameter, I think it takes an integer value as parameter. Time probably is given in seconds. Need to verify in the API, but mostly it is in seconds. Timeout in seconds. Okay. Set socket timeout. SO is socket. Set SO timeout. Method name is set SO timeout. What is this method for? Read, you remember, is a blocking method. Read is nothing but a blocking method. If you say read, it would wait till someone writes on the other side and is available. Fine. There's no data available. It would be blocked. It has to wait. Either the other side is closing the connection. Then he says, okay, I get an end of file. If he doesn't close the connection, he's waiting because there is some possibility of something being put on the output stream of the other side. Yeah, that's what the read is doing. Okay. So read is a blocking method, waiting. Okay, read being a blocking method, how long should it wait? There's nothing coming for so long. If nothing comes for so much time, I'll throw an exception. Fine. That would be in the read of input stream. The read method of input stream. This timeout is nothing but the timeout for the read method on the input stream. This socket timeout is a setting for the timeout. It's a setting of timeout for read method on the input stream of the socket. Okay, so when I'm reading from the socket, how will I read from the socket? By using the get input stream and then calling read method on that input stream. So it is that read method's timeout. That read method would throw exception after so much time. Okay, if there is no data available for so long, I've been waiting, 0 bytes come for so long, fine. Let me throw a timeout exception. Okay. Clear? So this is SO timeout. We also have the same method available in server socket. Void set SO timeout again for server socket. Parameter is an integer, probably in seconds mostly. Yeah, what is this server SO timeout for the server socket? We have the accept method. Recollect, we have got the accept method. Fine, in server socket there is the accept method, which is, we know, a blocking method. It waits for some client to connect, but no client connects for so long. In that case, the accept method would throw an exception and come out. Timeout. No one connecting to this server for so long, and therefore let's time out. Fine. By default, this value is -1, which would mean a infinite wait. Fine. Default is to wait infinitely. There's no timeout. Okay. By default, if you don't use the SO timeout, there's no timeout. Okay, it's waiting and waiting and waiting. Clear about the required methods? Fine. These are sufficient for our communication. Fine. We know the input stream, we know the output stream, we know how to handle them. Fine. And then we can create our application. Server side, 2 steps for having one connection. Fine, at least 2 steps. Initially, one step is there, which is nothing but for acquiring the port, and then onward is just one step, accept method. Just keep on calling accept method in a while loop. Fine, keep on calling them. So you keep on getting more and more clients. Yeah, we'll need to be handling more than one client, right? Accepting multiple connections should be there. Okay, so fine, we can try to have some code, and we can try to write some code for this. A very simple application. We can try to create one very simple server. Let's call it as our echo server. Fine. The purpose of this server would be, what this echo server would like to do, what we'll like to do through the echo server. A simple server waits for a client to connect. Whenever a client connects, fine, it can then, if the client connects, what should it do? Wait for an input from the client. Whatever input comes from the client, put it back on the output stream. So you read from the input stream of the socket on the server side and write back to the client on the output stream of the socket. Whatever you are receiving on the input stream of the socket, we'll put it back on the output stream. Fine. So anything what you type, you should see it back. Fine. Server will be designed so that client, if he sends anything, he should be getting it back. Now we need to write server, we need to write a client as well. Now we won't write a client initially. For client, we can initially use a general purpose thing. We'll be using what we call as the telnet. Fine, we might use telnet as a general, can be used as a general purpose TCP client. Fine, we might use telnet as a general purpose TCP client. Okay. Fine, so we can try that example. Fine.